My name is DanubePeerChains, and I'm manager of Laboratory for Industrial Design, Tech Lab Tehnopolis, which is equipped with several modern devices which employs different technologies. I am standing now next to our industrial 3D printer, which is classical example of device which employs additive technology. Additive technology started to implement into industry several decades ago, but many people says that still innovative technology. 3D printing is definitely for our laboratory the most important additive technology, and in our laboratory we have several 3D printers from different manufacturers with different characteristics, but what is the common for all of them is that they employ FDM printing technology. FDM printing technology basically represents the printing of plastics and creation of body layer by layer. 3D printing in general represents the creation of three-dimensional body or object based on 3D model designed in some design software. The design software on the market is relatively large, and there are many 3D modeling softwares. The software can be CAD or mesh, never mind. All of them can be used for production of 3D model, which later will serve as model for creation and production with 3D printer. Many people try to compare 3D printing technology with other technologies which is employed on the market, such as subtractive technologies or injection molding. All of those technologies has its own advantages and disadvantages, and I believe that the best way is not to compare each other, but try to find respective advantages and disadvantages and use all of those technologies simultaneously in order to achieve the best results. This is the way how we do at our laboratory, and we try to find the optimal way to use our 3D printers for production of projects. There are many advantages of 3D printing, and I will try to name some of them. Maybe the most important advantage of 3D printing is possibility to create complex objects with various design shapes, sizes, or from various materials with different colors. Here are some projects produced with our FDM 3D printer. As you can see, they all have different sizes and shapes, and some of those geometries is almost impossible to create with other technology. Even if it's possible, it maybe takes a lot of time, effort, energy, and at the end the money. So this advantage of 3D printer, I think it's obvious. As I mentioned, at our laboratory we possess several 3D printers which employs FDM technology. What is common for all of those printers is that they use plastic filament as raw material, which extruder melts on some temperature, depends on the type of the material, and creating the object layer by layer, and you can see raw material and final part after the process of 3D printing and some basic post-processing. As I said, I am standing next to our industrial 3D printer, which is a very capable machine. It has a large volume of 600 times 450 times 450 in 3 axes respectively. It has 2 extruders which can achieve high temperatures up to 500 degrees, which enables this machine to work with almost all thermoplastics available on the market. It can work with industrial grade, precision, quality, and industrial grade thermoplastics such as PEEK and PAIN. It has many options, such as these two heated compartments which can store up to 20 kilograms of material. So this machine is capable of doing very high, very large shapes with industrial grade quality and precision. First, and maybe the most important step of 3D printer is software preparation of project which we want to execute. For example, you can see here how the final object will look like after finishing of 3D printing process. As I said, for 3D printing we must have 3D digital model of object we want to produce. Also, I mentioned before that 3D printing is capable of producing of projects and objects with complex shape and geometry. As you can see, this project has a very complex shape and it's very suitable for 3D printing technology. Also, I mentioned before that we can produce the objects with different size and shapes, and also we can multiply the project very easily. As you can see, we can do this by software relatively easy. Almost every major 3D printing company for producing 3D printers has its own slicer software. So at the beginning, this software enables us to import some 3D digital model which we want to create by implementing 3D printing technology, and after slicing, which is done at the end after all of those parameters is set, will create G-code which tells the machine what it has to do. So here you can see the working area of our 3D printer. Here this light gray shows available area for 3D printing. So first step is to import some 3D object. For this purpose, let it be this object, and we can move it freely on the working area of our 3D printer. Next step is to choose the volume or the size of object we want to print. For example, this possibility is very useful for design and creation of functional prototype of some kind of new project. We can scale this object very easily, so we can increase or decrease its size, and this software is very intuitive. So for example, you can see now that this object changed its color. So what does it mean? It means that the size of this object is too large for our 3D printer and it cannot be printed. Also, if we move the object out of the working area, it becomes gray and it means it cannot slice, so the software immediately shows us the error we have done. So I will explain a little bit basics of this software. We can rotate this object in respect to all three axes, and we can move it, as I said, on the available working area of our 3D printer. Very important step which we must do every time is to choose material for our printing project. As I said before, 3D printing is it has advantage for working with many types of thermoplastics available on the market. On the market there are several hundred of different materials with different chemical and physical parameters, different colors, and you choose your material based on the project you will work with. So for example, here are represented 10 or even more common used material which has different chemical and physical properties, and we choose, for example, some of them, and you can see when we choose different material, the color of the object is changed. We must keep in mind that material which we order, which we determine in software, must be the same as material we loaded on the machine. So here in this software, which is very famous, there are, as you can see, many parameters which we can change in order to obtain the optimal printing parameters for our desired part. When we have set the printing parameters and we are satisfied with them, and when we positioned the object on the area of the printer as we wanted, then we press the button slice and we are telling the software to calculate and create the code which will later, tell the machine or our 3D printer what it shall do during the process of 3D printing. On the down right corner you can see information of time which will be necessary for the printer to finish this project, and what is very important for planning of some kind of serial production is amount of raw material or our thermoplastic which will be used during the printing process. These informations are very important, especially for planning, because you can achieve with optimization of printing process, you can achieve a lot of material. I mentioned many times that 3D printing is additive technology, and what does it mean? You can see now on the preview card. So here you can see how visually looks and how it will look the object we want to print after finishing. Software tells us that there is almost 1,000, there is a little bit more than 1,000 lines, and this software is very powerful. So as you can see, it shows the movement of extruder during the time for every layer. What does it mean that this technology is additive? As you can see now, you have empty space, or visually represented the area of our printer, but after printing starts, it creates the object from zero, layer by layer. Now you can see the first layer of printer, and you can see second, third, and you can see time lapse of production of our product. So you can see it adding, or it adds layer by layer, and that's why this technology is called additive technology. I mentioned before that this technology is environmentally very safe because, as you can see, it uses material only where is necessary. So there is for this project there is no waste of material at all. So it uses only material what is necessary to create this object. When we are satisfied with all printing parameters, when we visually confirmed that our project will end up with high quality, as well as time consumption and consumption of raw material, we can print it with USB card, directly putting into the 3D printer, or we can print it via cloud. This is very important option which enables us to control our printer remotely. We can set printer to work from our home, but just we have to keep in mind that the material which is chosen on our software is the same as material placed in 3D printer, and there is nothing on the printing board, and also the printing area of our 3D printer is prepared and clean as it should be before every printing project. Right now you can see how 3D printing process actually looks like in reality and why 3D printing is so called additive technology. At the beginning the space inside the printer was empty, but as time goes by, printer creates the model layer by layer until it has the same shape as 3D model we created by software. At all times you can see on the printer's display the remaining time and how much time remains until the printing project is over, as well as how the project will look like at the end and what was the actual time of the printing, as well as the material we used and the amount of the used material. First step for production of any product is to create and design 3D model in digital shape. And 3D printing is technology which enables the transfer of digital model into the three-dimensional body or object. 3D printing is very useful because it enables us to see and hold in our hands the functional prototype or final part which we designed in some kind of 3D modeling software. This software for slicing or preparation of printing projects, as I said, enables us to increase or decrease the size of project which we want to manufacture. And for example, after the printing, if we are not satisfied with the size of the object, we can easily change it in next iteration of printing process. This can save us a lot of money, because if we want to produce some of those projects traditionally, we will have to use maybe many different technologies and use a lot of time and effort, which at the end will increase the production cost. With 3D printing we reduce all of this because we don't need molds for production, and 3D printing is almost indispensable tool for production of products in small series. As I said before, the 3D printing shows its power the most efficiently when we combined it with other technologies, especially new ones. This, for example, is some 3D object or one gear which is obtained by use of 3D scanning process, and it helps us into the design process. For example, with this kind of object we can use generative design and reverse engineering to produce the final object, and we can use 3D printer to produce it. And if we are satisfied with our result, then we can use, for example, these 3 models as molds for mass serial production. 3D printing can be used as a first step or initial step into the designing and manufacturing of some final product which we will use for mass production. When we are satisfied with our design and we confirm that the shape and the size of project is adequate for our production, we can choose many materials available on the market. There are several hundreds of materials which are basically represented on this photo here. So we have many, but here are shown most frequently used types of thermoplastics for FDM printing technology. So here we have polypropylene, PLA, ABS, PVC, and other thermoplastics which are relatively cheap and affordable, and today you can use it even as a hobby or starting material for some kind of production, usually for functional prototypes. Here you have engineering grade materials which can be used as raw material for production of industrial grade materials. For example, some kind of gears, shafts, and spare parts which will be used in not so harsh environment, which will not suffer high loads or high stress, for example, high amount of RPM, and they can serve us as a spare part, especially if for nowadays when the transport of production of some parts is limited. And at the end you have high performance material. These materials cannot be printed with all of printers. For example, I showed our industrial grade printer can work with those materials and they are ready to be used in industrial purposes. They have high melting points, for example, and they can suffer a lot of force, and for example they can be used for high temperature environment. Their melting point can be up to few hundred Celsius, so they are suitable for those applications in high temperature environments. There are many materials available on the market. Some of them are stiff, some of them are rigid, but some of them can also be flexible. So you choose material based on project and environment in which you will use that final project, and of course based on purpose in which this project or object will be used at the end. Also, you must have in mind the production cost and efficiency, and as I said, when you choose material, you choose it also with respect to the price of material. But what is a very useful thing with 3D printing is, after the design and you set printing parameters, software will prepare and you can see at the end the time which is necessary for these 3 objects to be printed, and you can see the amount of material which will be used, and you can easily calculate the cost, and you can determine shall you use this technology for production, or for example you can lower down some of those objects if necessary, and then after slicing it again the amount of material will be less. What is one of the advantages of FDM technology is that you can choose by software, manipulating the software, the infill percentage of the body which you will produce by 3D printing. What does it mean? For example, practically, if you want to design and manufacture some object which will not suffer high amount of stress or load or force applying on it after the production, you can increase or decrease the percentage of infill. And what does it mean practically? You can see after software finish the calculation. So now I have chosen the low percent of infill because I suppose that this product will not be used in harsh environment. So you can see now percentage of filled object is very small, and you can see the amount of raw material used is significantly lower. But for example, if we want to produce object which need to be rigid and stiff, we just can increase the percentage of infill and again press slice. So this object will have 50% of infill and it will have a higher structural rigidity, so we can apply higher loads or higher forces. This is just example of the product, but it's very useful thing, especially for industrial grade objects and the projects which will be used for industrial purposes. This is only one of options which we can change by software, and by manipulating the software and using its full capabilities, we can first design and then prepare project for printing in ideal manner, so we are finally satisfied with the quality of the final product. As you can see, for example, now I increase the lines of the model and also increase the percentage. So finally at the end it takes little bit more time and little bit more raw material, but the structural rigidity will be also higher. All this what I said allows you to manipulate the software in order to obtain different results and give you a lot of space for imagination and creation, and you can use it in designing and prototyping some kind of project, and you can obtain project with different amount of structural rigidity, different amount of mass. For example, there are many projects when the mass of the object is crucial, so in that time or during that time you use those kind of project, you can lower down some of those parameters and you can save a lot of time and a lot of amount of material which is used, and you can be of course cost effective. 3D printing allows us to fast products and objects with complex geometry, and very distinctive geometry, as you can see on this demonstration right now. So here you can see product which can be used for medicine purposes and allows the patient to live more comfortably when it hurts its hands. You can see here some gear which is industrial or spare part, and you can see here some model which represents, for example, visual part or production of products on architecture or design, or for example science, as you can part printing, for example, parts of animals, bones, which is very useful, or it can be almost impossible to produce with other technologies, so it can be very cost effective. Here you can see you can manufacture these three completely different parts with different sizes and shapes, and which will be used in different fields of life, and you can have it very fast, in less than 1 day, and you can use a low amount of material, and the cost of production of these three projects is very cheap, especially concerning in mind the complexity of all of those three shapes. Now I will talk more about our most advanced machine, which employs additive technology. This is a machine which we use when we have necessity for creation of parts which must have high structure rigidity and high strength. The overall process of 3D metal printing consists in 3 parts, and I will briefly explain all of those parts. The first step is 3D printing of metal parts, and our Metalix does that part. It also employs additive technology, but the difference between FDM technology and this one is that this machine is capable of printing metallic parts. It can print from stainless steel, several types of tool steels, as well as copper and titanium. After the printing is done, we take the finished model and put it inside this machine. This machine is chemical debinder, where the printed part is treated with special chemicals, and it stays inside this machine around 12 to 15 hours. After the chemical treatment is finished, the parts must go on the drying container, where it's also stayed until it's fully dried. That process overall of chemical treatment and drying lasts around 20 hours. After the second step is finished, the parts goes inside this device. This is our sintering device, which is used for temperature treatment of the finished parts, and the parts are exposed on high temperatures. The highest temperature the parts are exposed is up to 1300 degrees of Celsius, and after the sintering process is finished, we obtain the final parts, and the parts has structural rigidity, and it can be used for purpose it's intended. This system of machines for 3D metal printing is state-of-the-art technology which enables the creation and production metallic parts which has complex shapes and are difficult, almost impossible to create in traditional methods such as metal injection molding or CNC technologies. The overall process of production of metallic parts is very fast, and from design 3D model until finished product, it only needs around 48 hours. Another advantage of this system of metal printing is precise control of mass of final object, where we can lower down the mess while keeping the structural rigidity and strength of the final object. In the next video, you can see the overall process of production final products by implementing additive technology of 3D metal printing.
Thank you.